Hello students, today we are going to see the solutions of Neet 2024 and we are also going to analyze the question paper, right? So let's start with question number 1. So this is question number 1. A tightly wound 100 turns coil of radius 10 centimeter carry a current of 7 ampere. The magnitude of the magnetic field at the center of the coil is. Now this is direct formula based question, okay? So direct formula based question. So I would say that it is an easy question. Okay, so what is the formula? Magnetic field at the center of the coil, that is mu naught Ni by 2R. Okay, direct formula. Mu naught Ni by 2R. Mu naught value given to us 4 pi into 10 to the power minus 7. So let's place it here. Number of turns given again. Number of turns are given 100. Here it is. So 100. Current is also given 7 ampere. So 7 by 2 into R. Radius value is also given in this one, where it is 10 centimeter. So 0.1. Okay, so this is cancelled here, this is 2 pi, and take this one up because this is 1 by 10, so it will go up. Okay, so 1 by 10, 10 goes up, this becomes 1000. So 2 pi, this pi also you write as 22 by 7 into 10 to the power minus 7 into 1000. From here 10 went up into 7. 7 also cancelled. So what you have now, 22 into 2, that is 44. 44 into 10 to the power minus 4, which we can write as 4.4 into 10 to the power minus 3. That is 4.4 millitesla. So answer is 1. Okay, 4.4 millitesla. Okay, let's see next one. Next question is match the list 1 with list 2. Okay, this is list 1 with material and this is list 2 with susceptibility. Okay, so what are the materials? Diamagnetic, ferromagnetic, paramagnetic, non-magnetic. Now first of all, what is susceptibility? Susceptibility is the ratio of induced magnetic moment per unit volume to outside magnetic field. So induced magnetic moment in diamagnetic material is always in opposite direction to the external magnetic field you are applying. Okay, so ratio becomes negative. Susceptibility of diamagnetic material is negative. Okay, so diamagnetic material, which one is negative in this one? This is 0, this is greater than 1, this is also greater than 0. Susceptibility greater than 0. So where it is less than 0? Here. 0 greater than susceptibility. So here answer is for diamagnetic, answer is this. Okay, so first one's answer is 2. So where it is? Here and there also. Okay, fine. Second one is ferromagnetic. Now ferromagnetics induced magnetic moment per unit volume is in the same direction as the external magnetic field. So susceptibility is very high. Very high means this one. So we will say that ferromagnetic. Okay, ferromagnetic is this third one. So which is the answer? Now you don't have to go for all the checking. You can see that this is the answer. First one second, second one's answer is third. This and this were the possible options, but here it is given 1. So it's gone. Let's see further now. Paramagnetic. Now paramagnetic also susceptibility is positive. It's not negative. So which one? This one. So we can say its answer is paramagnetic. Paramagnetic will go for 4. Yes, absolutely right. And then non-magnetic. Non-magnetic will have 0 susceptibility. Okay, so answer is yes. Answer is third. Clear? Okay, let's go ahead. A thermodynamic system is taken through the cycle ABCDA, the work done by the gas along the path BC. Okay, so what type of graph is this first of all? This is P and this is V. This is a PV graph. And what we can see in this one, in this entire cyclic process, AB is a constant pressure process, BC is constant volume, CD against constant pressure, this is constant volume. What is this asking? He is asking BC. Now BC is what? BC is constant volume. And if it's a constant volume, then where is the work done? No work done. Very conceptual question, and I would say it's easy again. It's an easy question. Okay, let's go ahead. Let's see what this question is now. An unpolarized light beam strikes a glass surface's Brewster's angle. Again, a conceptual question. Brewster's angle is which angle? The angle at which we can say the reflected light gets plane polarized. What is this angle? This is the angle if the incident ray is making that angle with the normal, then reflected ray is plane polarized and refracted ray is partially polarized. Conceptual question, should remember that. Okay, let's see what the options are. Both the reflected and reflected light will be completely polarized? No. The reflected light will be completely polarized, but the refracted light will be partially polarized. Yes, that's what I told you. The reflected light will be partially polarized. No. The refracted light will be completely polarized. No. It was a conceptual question. Answer is second. Okay. Direct question. So I would put this also as an easy question. Okay. Let's go to the next. In an ideal transformer, the turns ratio is NP by NS equal to 1 by 2. Then VP by VS is equal to. Again, direct formula. NP by NS equal to VP by VS equal to IS by IP. But since we are not talking about this at the moment, we are talking about these two only. So NP by NS is given 1 by 2, and what they are asking, VP by VS only. So that is only the ratio. So VP by VS is also 1:2 only. If they are asking VS by VP, we would have written 2. VP by VS is 1 by 2. Okay. Again, what type of question is this? Easy. Direct formula based. Okay. Let's go to the next one now. Fifth question. A logic circuit provides the output Y as per the following truth table. A logic circuit is given, okay, and its truth table is given. We have to identify what is Y here. Okay. So it says 0, 0, 1. A is also 0, B is also 0, but Y is coming 1. So that means definitely not is there. Definitely not is there, because if these two are AND, answer should be 0 only. 1 is coming. Even if this is OR, 0, 0, if we are having an OR also, output is 0. But here answer is coming 1. So definitely not is being used. No doubt about that. Okay. 0, 1. Now 0, 1, answer is coming 0. So if we are using not, we already said that not is there. Okay. Final one, answer is coming after not only. This is Y here. Okay. And here is A and here is B. That is, let's say this is A and this is B. Right. Now, in the first case, we could not determine whether it's OR gate or AND gate. We could not determine it. Or let's see the options itself. Option itself is good only, right? So, what says the options in this one? The expression for the output Y is B. B is absolutely wrong. B not will appear to be correct only, right? 0, 1, 1, 0, 0, 1, 1, 0. But let's go for the C1, third one. A dot B. Now, A dot B, okay, that means he's saying AND. So, A, B, let's see, let's check. This is A, this is B, and there is AND gate. Okay, then what? Plus A inverse. Okay. So, what to do? Plus A inverse. Plus means is there is OR gate is in that. Plus means is OR gate. Okay. So, here from here one output is coming. We'll check. Okay. Let's remove this one here right now. Okay. So, this is coming after AND, and then plus is this. And here it's putting this one. Okay. Now they are adding it. Which gate? OR gate. Like this. This is why. According to third option. Okay. Let's see whether it's correct. So first of all, we have 0, 0. Okay. So from here also 0. from here also 0. Okay, so here goes 0, 0, here comes 0. From here goes 0, now not means this is 1. 1 and 0 will give you 1. Okay, what is the answer here? Yes, 0, 0's answer is coming 1. Perfect, third option. Okay, second one, 0, 1. A is 0, B is 1. Okay, A is 0, B is 1. So A is 0, B is 1. Okay, so 0 and 1 goes in end, comes out to be 0 only. Okay, here goes 0, not, so comes 1. And again OR, comes 1. So 0, 1's answer is coming 1. That means, because here 0, 1 is coming 0, whereas here 0, 1's answer for us came out to be 1. So that means third is also not correct. Then what is fourth option? A, B negative plus A. Okay, fine. So I am changing this. Okay, this one we are removing right now. So we are making another one. What says A dot B negative. Okay. So A is here. Okay, and B is here. But B negation is going in end. Okay, because this is into. So end. Then what? Then OR gate is there and directly the signal is coming from A. Okay, fine. Like this. And here is OR. Okay, this is why. Alright, so now what are the signals? Signals we will take as 0, 0 first. Okay, fine. So 0, 0. So from here 0, from here also 0, but it becomes 1. So here is 0, 0, 1, here is 0. This is 0. Okay, and here also 0 only. So 0, 0, 0. 0, 0, 0. But here says 0, 0, 1. Again check. This is 0. This is also 0 only. But there is a negation here because he says B naught. So here comes 1. 0, 1. So this is AND gate. So here goes 0. From also here also 0. 0, 0, 0. So this fourth option is not possible. This fourth is not there. Then what to do? So which option is correct then? Only first option looks to be correct. Because B negation. B negation means 0 is 1, 1, 0, 0, 1, 1. Third option again we check. A dot B plus A. A dot B, that is A and B, and okay, plus negation of A. Okay, check one more time. 1, 1, 0 give check this time. Okay. So 1, 1, 0. So 1. Here is also 1. So 1 and 1 goes in end, comes out to be 1. Okay, here goes 1, becomes 0. 0 and 1 goes in OR, comes out to be 1. Okay, 1, 1 comes out to be 1, but our answer is what? 1, 1, answer is 1, but he says 1, 1, 0. So this is not possible. So only option possible is, we were knowing in the beginning only, but still we checked. So this question here becomes lengthy. Easy is okay, but lengthy. Right. Still, we had to check it. We were knowing this. This is pretty clear that this is B negation. Okay, but still, we were checking. Right. Next question. Okay. The next question, in a vernier calipers, n plus 1 divisions of vernier scale coincides with n division of main scale. If one main scale division represents 0.1 mm, the vernier constant. The vernier constant means is what? Least count. And one least count is what? One least count is one main scale division minus one vernier scale division. You should always remember. Okay. So then what is here? N plus 1 division of vernier scale coincides with n divisions of main scale. So we'll say, okay, n plus 1 divisions of vernier scale is equal to n divisions of main scale. That's what question is saying. So what I am trying to do? What I am trying to do is I am going to get the value of one vernier scale division in terms of main scale division so that I can keep it in this one, because I need to find the least count value. So 1 vernier scale division equal to what? N by n plus 1 main scale divisions. That is it. So this value I am going to put it in this one. So least count. Okay. What is least count? So least count is 1 main scale division minus n by n plus 1 main scale divisions. Okay, what's coming? N plus 1 minus n by n plus 1 main scale division. So we have 1 by n plus 1 main scale division. What is 1 main scale division? Is given 0.1. So 0.1 mm. So 0.1 mm by n plus 1 is our answer. Now check, is it there or not there? It says 100 n, no. 10 n plus 1, no. 1 by 10 n, no. 1 by 100 n plus 1. So my answer is not there. Let's check what is it. He said in centimeter. My answer is in millimeter. Convert it in centimeter. 1 millimeter equal to 1 by 10 centimeter. So 0.1. 0.1 it's also is 1 by 10 only. Okay. So this is also 1 by 10. And 1 mm means 1 by 10 of a centimeter by n plus 1. So my answer now is 1 by 100 into n plus 1. Again a conceptual question. Okay, but you have to calculate it, takes time. Okay, so I would put it into this moderate type of question. Okay, right, next one. The maximum elongation of a steel wire 1 meter length if the elastic limit of steel and its Young's modulus respectively are 8 into 10 to the power 8 and 2 into 10 to the power 11. Okay, now in this one there are certain things which you need to identify. What informations are given? Young's modulus is given, yes. 8 into 10 to the power 8, what is this here? Elastic limit. What is its unit? Newton per meter. So this is basically breaking stress. Breaking stress is given to you. Okay. Maximum elongation of a steel wire of 1 meter length. We have to find how much elongation you can give. But stress is given to you. Young's modulus is given to you. Now it's very easy question. Okay. Very easy. Because we all know that Young's modulus is equal to what? Stress by strain. Okay. Now strain equal to what? Strain equal to stress by y. Right? It is equal to stress by y. Strain. Strain is what? Delta L by L. And stress value directly given 8 into 10 to the power 8. Put it here. 8 into 10 to the power 8 by 2 into 10 to the power 11. This is 4. 4 into 10 to the power minus 3. So delta L equal to 4 into 10 to the power minus 3 into length is given 1 meter. So delta L is 4 into 10 to the power minus 3. That means 4 mm. This is our answer. Okay. Answer is third one. This is our answer. Okay. Let's move ahead. What type of question you will give? It's in moderate again. Not tough, but you need to know what is given. You need to identify. You should be able to identify. Okay. Right. What is this now? A horizontal force 10 Newton is applied to a block as shown in figure. The mass of the block A and B are 2 kg and 3 kg respectively. The block slides over a frictionless surface. Frictionless surface is this. The force exerted by block A on block B. How much force is exerted by A on B? So if 10 Newton force you are applying on this 2 kg and 2 kg is applying the force on 3 kg. So 2 kg can apply the force on 3 kg when they will be in contact obviously. So that means both are moving together. So 10 Newton is making this 5 kg to move together. What is acceleration? Say force. Force equal to mass into acceleration, right? Force equal to mass into acceleration. How much is force? 10. Mass is 5. Acceleration is what? 2. Is it acceleration of both the blocks? Answer is yes. Now the next question is, who's making this 3 kg block move? 2 kg. 2 kg is pushing it, right? Okay. So push given by 2 kg will say N into 3 into A. The same acceleration, no? Both are moving together. So who is pushing 3 kg? I said 2 kg only. The normal contact force between 2 kg and 3 kg is equal to 3A. So N is equal to what? 6 Newton. N is equal to 6 Newton. That's all. Over. Easy question. Okay. This was easy question. Right. Let's move ahead now. What this is now, let's see. If the monochromatic source in Young's double slit experiment is replaced by white light. Okay. So if you are replacing monochromatic source with a white light, what's going to happen? Let's talk about the central bright fringe, central maximum. In central maximum, what happens? From both the sources, the light travels, okay, and it travels the same distance. It travels the same distance. So at central bright, there is no path difference between the two. There is no phase difference between the two. That means we are going to get maximum. Maximum for all the colors. So if all the colors are there, then what will happen? It will be white. Central maxima will be white. There is no doubt about that. Then what will happen? As you move away, as you go away from the central maxima, then you are having certain path difference. Path difference will develop. And since wavelength of each color is different, so what will happen? Delta x, which we call as, what is delta x basically? Delta x will be for a maximum. For maximum intensity, delta x used to be n lambda. So since lambda for each one is different, okay, so path difference or the phase difference or eventually the maxima's position of each color will be different. Okay, central maxima is bright white. Okay, as you go, you are increasing the path difference. So every wavelength's path difference will be coming in a different way. Okay, that means what I am trying to say, I am saying that delta x is n lambda, right? So let's say for violet color, this will be n. Suppose n is 1. Okay, n we are saying is 1, right? Let's say this is 1. So delta x is 1 lambda, or lambda for violet, right? At this path difference, you are going to have maxima for violet color. For another, for red, it will be lambda red. For yellow, it will be lambda yellow. So delta x, which is corresponding for maximum intensity, is different for different colors. So position of every color will be different, but central bright is white. So what options are saying? Let's say there will be a central bright white fringe surrounded by a few colored fringes. This is correct, because colored fringes will be there. As I told you that, because delta x is different or corresponding to maximum intensity, delta x is different for different wavelengths. So that's why different color fringes will form. But central bright is, or central maxima is white. What is second option? All bright fringes will be of equal width. All bright fringes will be of equal width. Then interference pattern will disappear. There will be a central dark fringe surrounded by a few colored fringes. Fourth option is wrong. Interference pattern will disappear. Interference pattern will be there because maximum, minimum, you can see. Okay, intensities will be there. So this is wrong. All bright fringes will be of equal width. We cannot see them in this one because all will be overlapping the other one. All colors will be overlapping the other one. So we cannot see exactly. So that's why the correct answer is there will be a central bright white fringe surrounded by a few colored fringes. Okay, so yes, we will put this into slightly tougher one. Okay, unless it is discussed with you in the class, it is tough to imagine this one. Or if you have gone through this particular concept, it is tough for the students to come to the conclusion. Okay. Next one, the graph which shows the variation of 1 by lambda square and its kinetic energy E, where lambda is de Broglie wavelength of free particle. Okay, so when we talk about de Broglie wavelength as such, we have one main formula which says lambda equal to h by p, where p is the momentum of the particle. But he is asking in terms of kinetic energy. So let's convert this p into kinetic energy. P is what? We say root over 2m into kinetic energy. So lambda equal to h by root 2m kinetic energy. Right. What relation he wants? He wants relation between 1 by lambda square and kinetic energy. So 1 by lambda square means is I should be doing its square. So lambda square equal to what? Lambda square is equal to h square by 2m to kinetic energy. Now h square and 2m are constants. What relation I am getting? Lambda square is directly proportional to 1 by ke, or kinetic energy is directly proportional to 1 by lambda square. So this is a graph between what? 1 by lambda square and kinetic energy only. So there is a direct proportionality. Direct proportionality means only option 2. Only option 2. So our answer is this. Conceptual question, where you have to think little bit. Okay, so moderate to tough. Let's go to the next. In the following circuit, the equivalent capacitance between terminal A and terminal B is. Between A and B, what is the equivalent capacitance? But if you see clearly, this is a Wheatstone bridge. P by Q into R by S. So if it's a Wheatstone bridge, that means this capacitor is of no use. Then these two are in series. So 2 and 2 are in series. Means net capacitance here is 1. Same way here also 1. Then 1 and 1 are parallel. So answer is 2. Very easy question. This is easy. Okay. Very easy question. 2 microfarad. Okay, what is this? This is Wheatstone bridge. Wheatstone bridge is there, that means there is no current here. Okay. Then see next question now, question number 13. Now how it is? In the above diagram, a strong bar magnet is moving towards solenoid 2 from solenoid 1. The direction of induced current in solenoid 1 and that in solenoid 2 respectively are through the directions. So that means here we have to find the direction of induced current, and here also we have to find direction of induced current. Okay. Alright. So what we know is, as this magnet is going towards this solenoid, its magnetic flux is changing. Okay. So magnetic flux is changing means the magnetic flux through this solenoid is increasing. So what will happen? It will oppose it. So opposite, what will happen? It is going to produce here which pole? South pole. Okay. Here also south pole will develop, so that it can repel it or it can oppose this. This side, now this side, as this magnet is going away, so magnetic flux through this coil is decreasing. So what it will do? It will oppose that also. So how it will oppose? By attracting. So here is also south and here is also south. Okay, so south basically means what? South pole means is clockwise direction current. This is clockwise direction. Okay, so clockwise means is when I am going to see towards this solenoid here, it will appear to me as a clockwise current. Okay, so clockwise means is like this. You see that this way. Don't see this last one. Just before that you see. This is clockwise. Like this, like this, like this, like this, like this. So like this means is it's coming in this way. Like this. So current is coming from D to C. Okay, so D to C means this is here and this is also here. Now let's see here. So I have to turn in this way because I have to see this current clockwise here. This is clockwise. So clockwise is this. Okay, see this. see this, see this, see this here, see this here, see this here. That means this is coming from A to B. So A to B and D to C. So A to B and D to C means this. This is the answer. Okay. For this 13th question, answer is third option. Okay. Consider the following statements A and B and identify the correct answers. Okay, fine. For a solar cell, the IV characteristic lies in the fourth quadrant of the given graph. Yes. Yes, you should remember that. Okay, because solar cell, when you talk about, right, then I have to tell you about solar cell. You should remember that it's a characteristic. Okay. In a reverse bias PN junction diode, the current measured microampere is due to majority charge carriers. No, when you say microampere is there, it is because of minority charge carrier. The reverse bias PN junction current is because of minority charge carriers, not because of majority. Forward bias is majority. So this is wrong. This is correct. So which one is there? A is correct, but B is incorrect. Okay, first one correct and second one is incorrect. First one is what? The IV characteristic of solar cell is in fourth quadrant. Yes. Okay. What type of question? You have to remember it. It's not formula based directly. Okay, you have to remember. It's easy. It's a moderate. Alright. A light ray enters through a right angle prism at point P with the angle of incidence 30 degrees as shown. It travels through the prism parallel to its base, BC, and emerges along the face AC, the refractive index of the prism. Okay, now for refractive index of the prism, what we require? If you apply Snell's law on this one, okay. So through Snell's law, can we get refractive index? Answer is yes, we can get it. And what is the initial angle of incidence? Do we know it? It's given 30 degrees. So if I apply Snell's law over here, we can write that what? 1 sine 30 equal to mu sine R1. If I consider mu is the coefficient of refractive index of the prism, mu sine R1. Okay. Now this is 30 given. Alright. And this is also given that this is 90. Correct? Okay, fine. So this being 30 degrees here. Okay, this is 30. Okay, then what else now? This is R1. This is what we are looking for. This is R2. And this is given that the angle of emergence again is 90 degrees. So, what I can do? One thing I can do is the relation of this prism. We know that A is equal to R1 plus R2. Okay. A is always equal to R1 plus R2. This relation we know. Okay, fine. Second relation I can write for this surface. What is that? I can write this as 1 sine R2, or rather mu sine R2. Okay. What happened? Yeah. So mu sine R2 equal to 1 sine 90. Okay, because this is 90 over here. Alright. So now what relations are we getting? We are getting certain relations here. Sine R2. Now R2 I would like to write as A minus R1. Now what is A? A is 90, remember. So this one is 90 equal to R1 plus R2. Okay. So R2 equal to what? 90 minus R1. Equal to this mu you take down. So this is cos R1. Correct. And from here, can I get sin R1 value? Said yes. Sin 30 is 1 by 2. So 1 by 2 equal to mu sin R1. So sin R1 value is 1 by 2 mu. Correct. Now cos R1 I have, sin R1 I have. I can square them and add them. Cos square R1 plus sin square R1 should be equal to 1. So cos square R1 plus sin square R1 equal to 1. That means 1 by mu square plus 1 by 4 mu square equal to 1. Like, now take their LCM. So LCM is 4 mu square only. Then this is 4 plus 1 equal to 1. So 5 equal to 4 mu square. So my answer is mu equal to root 5 by 2. Mu equal to root 5 by 2. D option. Okay. Our answer is D option here. So how this slightly tougher, we can say. Lengthy and slightly tougher because you have to conclude a lot of things in that. Okay. Then question number 16. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Assertion A. The potential V at any axial point at 2 meter distance r from the center of the dipole moment vector P of magnitude 4 into 10 to the power minus 6 coulomb meter is 9 into 10 to the power 3 volt. We have to calculate. Okay. So at axial point, what is the formula? Now direct formula based question it is. Okay. V axial is 1 by 4 pi epsilon naught P by r square. 1 by 4 pi epsilon naught P by r square. Okay. So this is 9 into 10 to the power 9. P value 4 into 10 to the power minus 6 by r square. How much is r? How much is r given? 2 meters. So 2 meter means 2 square means 4. So what are we getting? We are getting 9 into 10 to the power 3 volt. What says here? What says this one? The potential V at any axial point at 2 meter distance from the center of the dipole moment vector P of magnitude this is 9 into 10 to the power 3. Absolutely fine. A option is correct. Reason V is equal to plus minus 2p by 4 pi epsilon naught r square, where r is the distance of any axial point. No, that is not 2p. It is p. P by 4 pi epsilon naught r square, not 2p by 4 pi epsilon naught r square. So reason seems to be wrong. So what is the answer then? A is true but R is false. A is true but R is false. Okay. Right. Then what we will say about this question? You should remember directly based on the formula. Okay. Easy if you remember it. The moment of inertia of a thin rod about an axis passing through its midpoint and perpendicular to the rod is 2400 gram centimeter square. The length of the 400 gram rod is near me. Okay. So moment of inertia about an axis passing through the midpoint and perpendicular to the rod. So moment of inertia is what? ml square by 12. Right. So moment of inertia here is ml square by 12 for the rod. Right. And its value given 2400 gram centimeter square. So 2400 into 12 equal to mass is also given 400 gram. So 400 gram into L square. Everything is in CGS. Okay. So this is cancelled. This is 6. So this comes out to be 72. Now 72 you can write as 9 into 8. So square root of this, square root of 9 is 3 and square root of 8 is 2 root. These many centimeters, so this is 6 root 2. I mean somewhere around 8.4 or 8.5 centimeter is going to come. 8.5. Okay, that's our answer. Okay, 8.4 is answer. Easy question. Next. The terminal voltage of the battery whose EMF is 10 volt and internal resistance 1 ohm when connected through an external resistance of 4 ohm as shown in figure is. That means you have to find out terminal potential difference of the battery. Now, if you remember formula also, what is the terminal potential of the battery? We say E minus IR because you are using the battery. E is given to us as 10. Now only thing is you have to find current. So what is the EMF of the battery? 10. What is the total resistance in the circuit? 5. So current will be what? 10 by 5. That is 2. So current is 2. Now what is the internal resistance? 1. Answer is 8. Very, very simple question. Very, very simple question. Okay. 8 volt. Then match list 1 with list 2. Spectral lines of hydrogen for transitions, and this is the wavelength. Okay. So N2 is 3 to N1. Now what is the formula for that? That formula you should know. You should remember the formula. Okay, direct formula is also there. So 1 by lambda equal to R 1 by N1 square minus 1 by N2 square. This is the formula. Okay, so he says N equal to 3 to N equal to 2. 3 to 2. So okay. So 1 by lambda. R value is what? 1.09 into 10 to the power 7. Okay. N 3 to 2. Okay. So 1 by 2 square minus 1 by 3 square. So what's going to come? 1 by lambda equal to 1.09 into 10 to the power 7. And here this is going to come, this is 36. Okay, so 9 minus 4, so that is 5. So what we are getting? Lambda equal to what? It says 36 by approximately 5 into 10 to the power 7. So what will come? It will come out to be 7.2. Okay, 7.2 into 10 to the power minus 7. Right? How it is given here? It's given in nanometer. So 10 to the power minus 9. So that means multiply with 100, divide with 100. So it will come 720. 720 nanometer. Okay, there is 720 nanometer, right? Okay, where is 720 nanometer? Near about the 656. Why like this? Because here was 1.09. We did not take it. So it will be less than 720. Okay. So where is less than 720? 656. So that means this can match with third option, like this. So where it is A option with the third one? Only in fourth. Only fourth option is matching. So shall we stop it? We can. But okay, let's go for one more. This one will go B. B option also we'll check. Okay. What should be our answer? Fourth one. Let's see. Okay. So now, fine. So lambda. Now, I'm not writing this formula again. Directly putting the value. Okay. So 1 by lambda equal to 1.09 into 10 to the power 7. Now, second one is what? 4 to 2. So 1 by 2 square minus 1 by 4 square. Okay, take its LCM. This is 16, this is 4. So LCM is 16. Here is 4, here is 1. Okay, and 1.09 into 10 to the power 7. Right, so this comes out to be 3 by 16. So lambda is equal to 16 by 3 into 10 to the power 7 approximately. So this will give you what? 5.33. So comes out to be 533 nanometer. Now check which is close to this. This is close to this. So second one's answer is fourth. So our answer is fourth option. Our answer is fourth option. Okay. This is our answer. What's happened? This is our answer, right? So how is this? Again, slightly lengthy, but I won't say that it is a tough question. Again, a formula based directly. Okay. Right, question number 20 is there. If c is the velocity of light in free space, the correct statements about photon among the following are. Conceptual question this is. Energy of a photon E is equal to h nu. Absolutely right. In terms of frequency, when we write the energy of photon, we write it as h nu only. Okay. Then, the velocity of a photon is c. Yeah. It travels with speed of light. The momentum of a photon P is equal to energy by C. That's also correct. How? Because we say that energy is mc square. For photon, energy is mc square. And momentum is mc. So E by P is what? M cancel, C cancel. Okay, so what it is? E equal to P into C. Same thing. So P equal to E by C. And E we have written as h nu. Perfect. There's no doubt about that. Okay, then in a photon electron collision, both total energy and total momentum are conserved. In a photon electron collision, then what happens? Electron actually absorbs entire energy of photon. Correct or not? In photon electron collision, both total energy and total momentum are conserved. Is it correct? Let's see then. Last one, photon possess positive charge. No, that's absolutely wrong. Photon doesn't possess any charge. So what options are there? We said that A, B, C are absolutely correct. So A, B, C are absolutely correct. Where it is? A, C and D, no. A, B, D and E, no. A and B, no. A, B, C and D only. Okay, so A, B, C are correct and D also is correct. We said that electron absorbs the entire energy of photon. Right? And in any type of collision, we know that momentum is always conserved. So here energy is also conserved and momentum is also conserved. So our answer is what? D. D option is correct. So this is our answer. D. Okay. Conceptual question again. But because we have to check all the four options, we can say it's lengthy. Alright. Okay, let's see now. Element X, alpha particle is moving out of it. Y is coming. From here, this is beta positive. Beta positive is coming, going out. Z is coming. From here, beta negative is going out. P is coming. And again, beta negative. This E means is beta negative only. Okay. So this alpha means is what we are decreasing? 2. We are decreasing here 2 and we are decreasing here 4. 2 He4 only, no alpha. So 2 decrease. That means here will come 80 and here will come 286. Okay. Now this is beta positive. So what is going actually? +1 E and it's 0. Okay. Wait a second. Yeah, that's fine. That's fine. No need to have any correction in this one. So what we have is +1 E0. So +1, this is decrease. So here comes 79. But here remains 286. Now here comes beta negative. Beta negative means -1 E0. -1 E0. So that means here it becomes 80 again. This is 80 and this is 286. This is again beta negative. So that is -1 E0. So here becomes 81 and this becomes 286. Okay, so atomic number is 81 and mass number is 286. Where it is? Second option. The second option is correct. Okay, you understood, no? This is alpha, this is for plus beta where you have atomic number is decreased, but here is negative beta. So atomic number is increased again. That means protons are increasing. Okay. Alright then, next. At any instant of time t, the displacement of any particle is given by 2t minus 1 under the influence of force of 5 Newton, the value of instantaneous power. Now instantaneous power's formula is what? Force into velocity. Okay. Instantaneous power is given as F dot V. So force is given, T is constant force. Now velocity we have to find, but displacement is given. What we can do? ds by dt we can do. That is only the instantaneous velocity. So what we have to differentiate? 2t minus 1. 1 is constant, forget it, 2t, differentiation will be 2. So power is coming as 5 into 2, that is 10. Very easy question. Okay, answer is 10. Now let's see this question. How to solve this question now? See then, this is related to our logic gates. So this is AND given, this is OR given, and in front of that NOT is connected. And this is also OR, and one more NOT is connected over here. Okay. So shall we solve? Shall we give the signals and make the truth table and see? Okay. Let's see them. So first of all, let's have 0, 0 here. 0 and 0. So here goes 0. Okay. 0, 0 goes. This is AND. So what is going to come out? 0 only. 0, but this is not here. So not will make it 1. So here goes 1. Okay. Same way here is also 0. 0, 0. OR will make it 0. But here again not is there. So 1, 1. 1, 1 goes in OR. That means 1. But not makes it 0. So 0, 0's answer is coming 0. Okay. Next one. Next one, let's have 0, 1. So here comes 0. So already for 0, we said that here 1 is coming. So here also 1 will come. But in this case now this is 1. So here goes 1. This OR will give it 1 only. So then not is there, here comes 0. 0 and 1 in OR means 1. But here is not. So it will make it 0. Oh, oh. So for 0, 0 also 0. 0, 1 is also 0. Okay. Then what next? Next is we will make is 1, 0. So 1 is going here. And will give is 1. Then this will make it 0. So here is 0. Here 0. This goes here. This goes into OR 0 only. This will make it 1. Oh, 0, 1. So 0, 1. This is OR. OR will make it 1. But not will give it 0. Oh. I think this is going towards AND gate. Okay, last one now. Last one. Which one shall we take? Red one. Okay. So last one will make 1, 1. So here is 1. So 1 means it will be similar only, no, in this one. In the previous case also 1, we got 0 here. So 1 is here is also 0. Okay. Then here is 1. So this goes 1. OR makes it 1. This makes it 0. So 0, 0. 0, 0 goes in OR. Comes out to be 0, but this is not. So 1. Yes, our answer is AND gate. Okay, that's the AND gate. Okay, next. Question number 24. Question number 24 is the mass of a planet is 1/10 of that of the Earth and its diameter is half that of the Earth. The acceleration due to gravity. Now, acceleration due to gravity's formula we should remember, and only we can do that. What is the formula? G is equal to gm by r square. What is m? Mass of Earth, r, radius of the Earth. And what is its value? Because he is asking value, no? So its value actually 9.8, but I am going to take as 10 because in calculation it becomes easy. Okay, then what? He wants it for any other planet whose mass is 1/10 of the Earth and diameter is half. That means radius is half of the Earth. So G dash is equal to G into m by 10 and radius is half. Okay, so what are we getting? This 4 will go at the top. So 4 G m by 10 r square. Correct? No, it's 10 and then r square. This value I know is 10. So 4 by 10 into 10. So G dash is 4. So approximately 4. Which one is there? Approximately 4 means 3.92. 3.92 is our answer. Why not 4.9? The reason is because G value we have taken 10. Actually it's 9.8. Okay, so 9.8 by 10 will be there. So it should be slightly less than 4. It cannot be 5. So it should be this. Okay. Next. Given below are two statements. Statement 1, atoms are electrically neutral as they contain equal number of positive and negative charges. Absolutely fine. Atoms are electrically neutral. Atoms of each element are stable and emit their characteristic spectrum. The atoms of each element are stable. Okay. When the atoms are stable, at that time, they don't emit any spectrum. Okay. If they are stable, he has given, then they should not be emitting any spectrum. When they are unstable, then only they release energy. When they are already stable, they do not release energy. So in this one, my answer is first one. Statement 1 is correct, but statement 2 is incorrect. Okay. If the elements are stable, they are not going to emit any spectrum, any wavelength they are not going to emit. Okay. Next, a wheel of bullock cart is rolling on a level road as shown in figure. If its linear speed is v in the direction shown, which one of the following option is correct? Now it's rolling. Okay. So we all know that the topmost point's velocity will be highest and this point's velocity will be 0. Then only it will be rolling. Rolling means is no slipping. No slipping means is contact points should not be having any relative motion. So ground is at rest. So this point also should be at rest. Whereas this point's velocity will be what? V plus r omega. We know that. This is omega. Okay. And what is omega and v relation? Should be v equal to r omega. So that means this will have 2v velocity and this will have 0 velocity. What it says? Both the points P and Q move with the equal speed? No. Point P has 0 speed? Not at all. Point B moves slower? No. Point B moves faster than point Q? Absolutely. This is actually 0, this is actually 2B. So our answer is 4. Okay. Next. A particle moving with uniform speed in a circular path maintains. A circular path. Particle is moving in circular path. Okay. The circular path is like this. Constant velocity? No way. Direction is changing. Here it's like this, here it's like this, here it's like this. How is constant velocity? No way. Constant velocity? No. Varying velocity? Yes, because direction is changing, so it's called varying velocity. Varying acceleration also? Yes, because acceleration also is changing, direction is changing. Always we have centripetal acceleration in this direction, but tangential acceleration is in this direction. So where is the resultant acceleration? Here. But when you talk about this point, centripetal is like this, tangential is like this, so it is in this way. So direction of acceleration here is changing. Direction of velocity also changing, direction of acceleration also changing. So we'll go for second option. Okay. Next, a thin flat circular disc of radius 4.5 centimeter is placed gently over the surface of water. Disc is placed. If surface tension of water is 0.07 Newton per meter, then the excess force required to take it away from the surface is. First of all is how much force is surface tension applying on that. Okay, so it's a disc we are saying. It's a disc. Okay, and we know that surface tension x on the length. So which length? This length. Okay, so force due to surface tension will be what? Surface tension into length, that is 2 pi r. That's it. Yes, that's it. The surface tension is 0.07 Newton per meter and radius is given to is 4.5 centimeter. So 2 pi, so 2 into 22 by 7 I will write. That's why this is given in 7. Okay, and radius is 4.5 centimeter. So convert it in meters. Okay, so what we have now? This is 0.07, that means 1 by 100. Okay, this 7 we can cancel now. Now this is what? 1 by 100 here into 44 into 4.5 and this is also 100. So 10 to the power minus 4 is there. This one 10 to the power minus 4. Okay, so 44 into 4.5 into 10 to the power minus 4. But they are asking in terms of milli. So okay, fine. We can write this as 4.4 into 4.5 into 10 to the power minus 3 Newton. So 4.54 into 4.5 will be how much? Around 20. Around 20. So what is our answer? 19.8 milli. 19.8 millinewton. Okay. Next, In a uniform magnetic field of 0.049 Tesla, a magnetic needle performs 20 complete oscillations in 5 seconds is shown. Moment of inertia of the needle is 9.8 into 10 to the power minus 6. If the magnitude of magnetic moment of the needle is x into 10 to the power minus 5, then the value of x is. It's a simple harmonic motion question given in magnetic field. Okay. Alright, let's solve. So what we can do? First of all, we can see that what is the torque in this one, because torque only will be restoration torque. So torque formula is mb sine theta or mb if I consider theta is 90. The torque is mb, and torque only we can write as I alpha. This is m. So alpha equal to mb by I. Now this is restoration torque. Remember that negative sign I am not putting in that. Okay. So this alpha is what now? Or I should write mb sine theta. Okay. Because I am doing it in a proper way. So let's sine theta also is. Now alpha, if it is angular is SHM, then I should write it as omega square theta. And if this is sine theta and it is very small, then this should be also be theta. So this is how it is. So omega value is actually root mb by I. So time period is 2 pi root over I by mb. I is moment of inertia. Now we have the formula. Okay, and time period is how much? He says is 20 complete oscillation in 5 seconds. In 5 seconds, 20 oscillations. So time period is what? In one oscillation, how much time it has taken? 5 by 20, that is 1 by 4. So put it here, 1 by 4. 2 pi. Now put the values. I value is given 9.8 into 10 to the power minus 6. If you remember the formula this directly, then it will save your time. Okay, 9.8 into 10 to the power minus 6. Then m, magnetic moment only, actually we are finding. So let it be m only. I am not putting anything. And magnetic field is 0.049. 0.049. So what we can do that? 49 into 10 to the power minus 3 or 4.9 into 10 to the power minus 2. Right? Correct. Okay. So why I did this? Because so that we can cancel this one, 4.9 and this is 2. And with this one, this will be 10 to the power minus 4. So directly we can take it outside. So 1 by 4 equal to 2 pi. Now what I have? 2 into 10 to the power minus 4 is there. That means you cannot take it out that easily. Huh? You have to square it. Okay, we'll square it now. So if we are squaring it, answer in terms of pi. So you should not change pi. Pi should be there only. So square it means 1 by 16 equal to 4 pi square into 2 into 10 to the power minus 4 by. Now m value you keep. M value is given x into 10 to the power minus 5. Okay, so x value you can take that side because x you have to find. So x will be equal to what? 16 into 4. 64 into 2. 128 pi square. 1280 pi square. That's all. Yes. That's the answer. Okay. This is our answer. Lengthy question. And put it as tough also because it's not necessary that you will be directly you will be getting its answer. Okay. Then two bodies A and B of same mass undergo completely inelastic one-dimensional collision. A body A moves with velocity v1 while body B is at rest before collision. The velocity of the system after collision is v2. The relation v1 and v2 is. Okay. Two bodies of same mass undergo completely inelastic one-dimensional collision. Okay, so before collision, what was there? One body was there at rest and one body was moving with speed v1. Masses are m. And after collision, what will happen? Both will move, but both will move together as mass 2m and they will move with v2. So what we know? We know that the momentum is conserved. In any type of collision, momentum is conserved. So what is initial momentum before collision? Say mv1. Final momentum after collision, 2mv2. Both are equal, right? Yes. So mv1 equal to 2mv2. He is asking v1 by v2. Am I correct? Yes. v1 by v2. What is v1 by 2? 2 is to 1. Answer is fourth. Right? Okay. Easy question. Very easy. Next. If x equal to 5 sine pi t plus pi by 3 meter represents the motion of a particle executing SHM, the amplitude and time period of motion respectively are. This is amplitude, 5 meter. So answer is either 2 or 4. Okay. Then time period. Now, coefficient of t is omega. So omega is given pi. And what is omega? 2 pi by t. I cancel. T equal to what? 2 seconds. So my answer is 4. Very easy question. Very basic. Next. The quantities which have the same dimension as those of solid angle. Solid angle's dimensions. Solid angle doesn't have dimensions. Okay, it doesn't have dimension. It's a dimensionless. So that means I have to find out which quantities are dimensionless in this. Strain, yes, strain is dimensionless. But arc means its length. Arc does have dimension. Angular speed and stress. Angular speed has dimensions. Stress also has dimension. Strain and angle. Yeah, this looks to be correct. Strain and plane angle. Angle, anyhow, it doesn't have dimension, whether it's solid angle or plane angle. And strain also is a ratio of length by length, change in length to original length. So dimensionless both. But this stresses again have dimensions same as pressure. Okay. So this is wrong. Only this is correct. Okay. Conceptual question, good question. Tough or easy? You can put it in moderate. Okay. A thin spherical shell is charged by some source. The potential difference between 2 points C and P shown in figure. Now this is a thin spherical shell. Charge is on its surface. So inside electric field is 0. When inside electric field is 0 means potential difference between any 2 points is 0. Means whatever is potential on the surface, same will be potential here inside. So what he wants, potential difference between the 2 points C and P. C and where is P? Not visible here. Not visible, but it is somewhere inside. Okay, our answer is 0. Right? Okay. So answer is 0 because this is equipotential surface now. Alright then. A bob is whirled in a horizontal plane by means of a string with an initial speed of omega rpm. The tension in the string is T. If the speed becomes 2 omega while keeping the same radius, the tension in the string becomes. Okay. So if this is how we are rotating it and this is the string, so tension is inside. Okay, radius is given same, so radius we say is r. He says initial speed is omega rpm. Okay, so normally omega we require in rps. So omega rpm means our omega actually, let's say omega dash is actually what? Omega by 60. Right. Now this tension is equal to what? We'll say that there is a centrifugal force which will be m omega dash square into r. This is tension. Now he says in the second case he doubles the omega, it becomes 2 omega. So our omega double dash has become what? 2 omega by 60. So now, if suppose the T dash I am writing, T dash or T dash is this only, okay, T double dash will be equal to M, okay, T dash will be, T double dash will be equal to M omega double dash square into R. Okay, he's asking tension only. So let's get the relation directly. Okay, T dash value is M omega dash square R and here T double dash. So let's take this. This is M cancelled, this R is cancelled. T dash value is given to you as T only. This is T. So T by T double dash equal to omega dash. Now omega dash means is what? Omega square by 60. Omega square by 60 square. Whereas here is omega double dash. Omega double dash is this. So 4 omega square by 60 square. So 60 square is cancelled. Omega square cancels. So T by T double dash is equal to 1 by 4. So T double dash is 4 times T. It's like unnecessary they have tried to confuse you by giving RPM. Okay, if you understand that, you can do it directly. It's an easy question but confusing. A wire of length L and resistance 100 ohm is divided into 10 equal parts. The first 5 parts are connected in series while the next 5 parts are connected in parallel. The two combinations are again connected in series. The resistance of this final combination. So wire of length L and resistance is divided into 10 equal parts. So that means you are making 10 parts of the same. So length will become L by 10 and resistance of each will become 10. Okay. Each part's resistance is what? 10. Each part's resistance is 10. Okay, now what you are doing? First 5 parts are connected in series. So when you are connecting them in series, resistance will become 50 because it's added. R series is 50 ohm. Then what? The next 5 parts are connected in parallel. So next 5 parts are connected in parallel. Each one is of 10 ohm. So 1 by R equal to 1 by 10 plus, I am finding it, okay, R parallel. 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10 plus 1 by 10. That is 5 by 10. That is 1 by 2. So R parallel is 2. Then what? The two combinations are again connected in series. This and this you are connecting in series. So net resistance of 52. Very simple question. Okay, then section B started from here. The following graph represents TV curve. This is T, this is V. TV curve of an ideal gas where T is the temperature and V is the volume at 3 pressures P1, P2 and P3 compared with those of Charles' law represented as dotted line. Pressure is constant in them, right? So he is asking relation between pressures. So what we have in ideal gas equation, if we just see, PV equal to nRT. Okay, N and R are constant, so we say PV is proportional to T. And P is proportional to T by V. Now, if I am talking about TV graph, then this is the slope of TV graph. So P is proportional to slope of TV graph. Okay, so whose slope is more? This is one, this is other one, and this is third one. Looks like the slope of P1 is more. This curves. So P1 will be more than P2 will be more than P3. P1 is greater than P2 is greater than P3. This is TV graph. Okay, it's given that. It's a TV graph. Okay, so answer is P1 is greater than P2 is greater than P3. Okay, let's move ahead. This is conceptual. Okay, next. A parallel plate capacitor is charged by connecting it to a battery through a resistor. If I is the current in the circuit, then in the gap between the plates, displacement current of magnitude equal to I flows in a direction opposite to that of I. No. If there is capacitor and this is how the battery is connected, if conduction current is like this, then displacement current also will be like this only, and displacement current's value will be equal to the conduction current on. The displacement current of magnitude greater, no chance. There is no current, no. Displacement current of magnitude equal to I flows in the same direction as I. Conceptual question, easy question. 38. The property which is not of an electromagnetic wave traveling in free space is that they travel with a speed equal to root over 1 by, yes, C is actually equal to 1 by root over epsilon naught mu naught. So they travel with a speed equal to, yes, they originate from a charge moving with uniform speed. Charge moving with uniform speed? No. When charge accelerates. Okay, so this seems to be wrong, but okay, fine. Third one, they are transverse in nature. Yes, electromagnetic waves are transverse. The energy density in electric field is equal to energy density in magnetic field. Yes. So what we have to find? The property which is not of an electromagnetic. The second one. Okay. Next. Students, let's see this question now. Choose the correct circuit which can achieve the bridge balance, which is possible over here. Which bridge balance is possible, that we have to check. Okay. So let's see. Now in this one we have to check now, because in this one batteries are given in different way. This is positive, so this is positive here, this is negative. Now see that 10 by 15 here, this is 10, and this you see that this is forward bias. So forward bias, normally resistance we take as 0 or very less resistance. Okay, this is shorted here. So these two are parallel, so their resistance will become even more lesser. So this is not possible, because normally for bridge balance this resistance ratio should be same, 10 by 15, here also it should be 10 by 15. So is it possible over here? No, its resistance will be even less than 5. Okay, see here. Now this is negative here and this is positive. This is positive means this is reverse bias. This is reverse bias here. The reverse bias resistance very high, infinite in fact. So it will not, no current will pass through this one. This is also not possible. This option you will see. What is here? This is positive here, this is negative. The positive negative means this is forward bias here. So if it's resistance, we consider some resistance is there. So there is a possibility that it can balance it. Let's see D option, that also we should see, then only we can see final answer. So this one you see that this is positive, this is negative. This is again reverse bias here. So again this is open circuit, so no current will pass. So only possibility is third one. Only possibility comes out to be third one. Okay. Let's go for the next now. Question number 40. If the plates of parallel plate capacitor connected to a battery are moved close to each other. So if you are moving close, so C basically is what? Epsilon naught A by D. So if you are making these plates to go close to each other, that means you are decreasing D. That means C is increasing. You can say C dash is more than C, right? First thing. Let's see now what they are saying. The charge stored in it increases. Now if it is connected with the battery, and he says that. So potential difference is constant. So new charge will become C dash V, which is obviously more than Q. Okay. So Q dash is more than Q. So Q is increased. Yes, charge is increased. That means this is correct. The energy stored in it decreases. Energy is half CV square, right? So if C is increasing and V is same, so that means energy should increase. So this is wrong. What we have to find out? Okay, multiple we have to check that. Is in capacitance increases? Yes. The ratio of the charge to its potential remains the same. Ratio of charge to potential. Charge to potential ratio is what? That's capacitance only. No? So capacitance has increased. So how can it be same? Okay. So the ratio of charge to its potential does not remain same. The product of charge and voltage increases. The product of charge and voltage, that means Q is equal to CV into V, CV square increases. Yes, because C has increased. So this is correct. Product of charge and voltage increases. So this is correct. This is correct. This is correct. This is correct. ACE. So answer is 4. ACE. Perfect. Next. A force defined by F equal to alpha t square plus beta t x on a particle at a given time t, the factor which is dimensionless if alpha and beta are constants. Okay, the factor which is dimensionless out of these four options given to us. Okay, so force here. Okay, so force equal to alpha t square plus beta t. Now, since they are an equation, so its dimensions also will be same as force, and this dimension also will be same as force. So if I look at this one, I will say that alpha basically will have dimensions of f by t square and beta will have dimensions of f by t. Correct. So now what is given? Alpha beta t. So alpha into beta. Alpha beta t. First option I am checking. Alpha beta t. That means f by t square into f by t into t. This is not dimensionless. This is wrong. B option then. Okay. B option, let's see. B option says alpha beta by t. This also doesn't look like. Why? Because this is f by t square. This is f by t and by t. How can this be dimensionless? B is also wrong. Then beta t by alpha. Let's check. Beta t by alpha. Now beta is f by t into t by f by t square. No, 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 no. It's not dimensionless. Then only option left is D. But let's check first. Okay. That is alpha t by beta. Alpha means f by t square into t. Yes, it's correct. And beta is f by t. Perfect. This is dimensionless. So our answer is 4. Okay. This is correct. Then a metallic bar of Young's modulus 0.5 into 10 to the power 11 Newton per meter square and coefficient of linear thermal expansion 10 to the power minus 5 per degree centigrade. Length 1 meter, cross section area 10 to the power minus 3 is heated from 0 to 100 without expansion or bending. The compressive force developed in it. That means we are heating in it. Normally expansion should happen. There is no doubt about that. But you have kept inside or between the two walls so that they are not able to increase. So walls are actually putting a compressive stress on that. So that's the question is asked. So how much is compressive stress developed in it? Okay. So we all know that if we are going to talk in terms of elasticity, we know that delta L by L, that is strain, is equal to F by AY. Now here F only we are calculating. Okay. And delta L by L, is it coming? Yes, it's coming because of thermal. Okay, because of heating. So delta L by L is what? Alpha delta T into A into Y. That is force. So just formula we have to remember and we can place the value. Yes. Alpha is what? 10 to the power minus 5. So put 10 to the power minus 5. Delta T value is coming what? 100. 0 degree centigrade to 100 degree centigrade. So 100. Area value. What is area in this one? Area, where it is? Length 1 meter, area of cross section 10 to the power minus 3. So 10 to the power minus 3. Now Young's modulus. What is that? 5 into 10 to the power 10. Okay. So 10 to the power minus 5, 10 to the power minus 8, 10 to the power minus 8. This is 10 to the power 10. So 10 to the power 2. 5 into 10 to the power 2 into 100. So 5 into 10 to the power 4 is coming. Let's see. Is it there? 5 into 10 to the power 4. It is there. This is 5 into 10 to the power 4. That's our answer. Easy question if you remember. Okay. Then a small telescope has an objective of focal length 140 and an eyepiece of focal length 5. The magnifying power of telescope for viewing a distant object. That means in relaxed eye he is asking. So magnification is what? FO by FE, direct. That is 140 by 5, 28. Okay, then easy question. An iron bar of length L has magnetic moment M. It is bent at the middle of its length such that the two arms make an angle 60 degrees with each other. The magnetic moment of this new magnet. Okay. So one magnet is there. Like this is a magnet. Okay, one line only like this. Length is L and its magnetic moment is M. Now what you did from the middle, okay, it is bent at the middle of its length such that the two arms make an angle 60 degrees. Okay, so you bend it like this. This angle is 60. Now remember that this is, we can say, is positive pole strength and this is negative pole strength. So negative pole strength came here. Okay, total length was L. Now this is L by 2 and this is L by 2. Now what will be, what the question is asking? New magnetic moment. Now new magnetic moment will be here. Now this length I have to find because magnetic moment is pole strength into length. Initial magnetic moment M that was given to us was M into L. But now how much it is, that we have to see. Now this is L by 2, this is L by 2, this is 60. So make a perpendicular over here, this is 30 degrees. Okay, this is 90. So this will become L by 2 sine 30. L by 2 sine 30 means L by 4. And this is also L by 4. So that means length has become L by 2. So now new magnetic moment will become M into L by 2 because this is L by 2 here. So magnetic moment has become half. So new magnetic moment is half. So answer is 4. Okay, next. A 10 microfarad capacitor is connected to a 210 volt 50 hertz source. That means AC source. The peak current in the circuit is nearly. Peak current he is asking, and what is this 210? This is RMS value. We need to be careful. Okay, so first let's get what is the IRMS. Then we will talk about peak. Okay, so IRMS is what? VRMS by, now only capacitor is given. So resistance we will write as XC. Okay, so VRMS is what? 210. XC means 1 by omega C. Okay, omega means 2 pi into frequency and C is this. So this will go at the top. So 210, 2 pi into frequency is 50 and C value is given to us as 10 microfarad. So 10 into 10 to the power minus 6. What is coming? This is 210, this is 100 pi into 10 to the power minus 5. In which way it is given? Okay. So pi value 210, 22 by 7 you write. 210 into 100 into 22 by 7 into 10 to the power minus 5. So this becomes here 30. 1, 2, 3, 3 zeros we can take from there. Okay. So this is 3 into 22, 6 into 10 to the power minus 2. This is IRMS value. Now I naught, I peak is IRMS into root 2. Okay, so this is root 2 into 66 into 10 to the power minus 2. Somewhere around 93, 94 into 10 to the power minus 2. So 0.93 will come. How? Because root 2 is approximately 1.4. Right or not? So 1.4 into 66 will come there somewhere around 93, 94. Okay. Alright, let's move ahead. Two heaters A and B have power rating of 1 kilowatt and 2 kilowatt respectively. Those two are first connected in series and then in parallel to a fixed power source. The ratio of power output for these two cases is first connected in series, then in parallel. Okay, so first of all, what is required? Two heaters A and B have power rating of 1 kilowatt and 2 kilowatts. Power rating. So with power rating, what we do? We calculate the resistances. Okay, so P, first one is 1 kilowatt. So I am saying one is P and one is 2P. Okay, this is P and this is 2P. Right? Or shall we keep 1 kilowatt and 2 kilowatt? Okay, we can. So P equal to V square by R1. So R1 value is V square by P. Same way R2 value will come as V square by 2P. Correct? So what is the relation between them? What is the relation? Say R2 is equal to R1 by 2. Remember that. That is important for us. Now he says both are connected in series first. So when they are connected in series, the net resistance is what? R1 plus R2. So R1 plus R1 by 2. That means 3R1 by 2. This series. Then they say they in parallel also they are connecting. Okay. So parallel when they are connecting, then what will happen? Say R1 R2 by R1 plus R2. So R1 R2 means what? R1 into R2, which is R1 by 2 by R1 plus R2 means 3R1 by 2. So 3R1 by 2, this is cancelled. This is R1 by 3. So in parallel resistance is R1 by 3, in series it is 3R1 by 2. Now what? The ratio of power output for these two cases. Okay, so in series first, power output in series. Series. So what you will say? V square by this, whatever V square is, V square by 3R1 by 2. Then P out parallel, again V square by R1 by 3. Okay, they want ratio. Ratio means like this. R1 gets cancelled. Okay, then V square gets cancelled. It's coming 2 by 9. It's coming 2 by 9. So the answer is 2 by 9. That is it. Slightly lengthy, or we can say tough also. Okay, 47. The velocity time plot of a motion of a body is shown. The acceleration time graph we have to make. Okay. So you see that in this one, this is, there is no velocity given, zero velocity is over here. So that will not be here. In all the options you see that initial is. Now here this velocity is increasing, that is acceleration is there. And you can see that this slope is constant. The slope of VT graph only acceleration. The constant slope and positive, right? So constant slope and positive. So constant is here, positive is also there, and here is given negative. This is variable, this is only option is 1. Then here you see that here slope is 0, that means acceleration 0 in this zone. Here negative slope, so negative acceleration, absolutely, first is correct. Then if the mass of the bob in a simple pendulum is increased to thrice its original mass and its length is made half its original length, then the new time period of oscillation is x by 2. X by 2 times its original time period, then the value of x is. So he is saying something like t dash is equal to x by 2 times t. Okay, let's put the value what is. T dash is what? 2 pi. What is time period? 2 pi root over L by G, no? Okay. So what he says is the mass of the bob in simple pendulum is thrice its original mass and its length is made half of the original. 2 pi root over L by 2 by G. Mass is anyway here. Nothing to do with mass. So they are making us fool here, right? X by 2 into 2 pi root over L by G. 2 pi cancel. Now what shall I square it? So L by 2G equal to x square by 4 into L by G. So L by G cancel. 2 and this 2 is cancelled. So x is coming root 2. Okay, x is root 2. That's it. Next, 49. The minimum energy required to launch a satellite of mass m from the surface of Earth of mass m and radius r in a circular orbit at an altitude of 2r from the surface of the Earth. We know that in this one conservative force, gravitation force is there. So energy will remain conserved. Okay. So first let's understand what they want. The minimum energy required to launch a satellite of mass m from the surface of Earth. So first this is, let's say, Earth. Okay, mass is m and this is our Earth. Radius is r. Okay, now from here you want to launch one satellite in a circular orbit at an altitude of 2r. That means radius will be 3r. So somewhere here, radius is 3r. So from this place, you want to send it to this place. Right. So what shall we do? Total energy is conserved. Okay. So total energy is conserved. Total energy is conserved. Right. So kinetic energy plus potential energy initial is equal to kinetic energy plus potential energy final. Okay. Now kinetic energy, what they are asking us, I think kinetic energy, minimum energy required to launch a satellite from the surface of Earth. That means they are asking you this value. Okay. Potential energy initial we know, minus G m by r. Now total energy in this satellite will be how much? Negative half of potential energy. What is potential energy? Minus Gmm by 3r. Half of that, minus Gmm by 6r. We know now total energy is half of potential energy, right? So this value will go there. So kinetic energy initial that we want is actually Gmm by r minus Gmm by 6r. So 5 by 6 is coming. If this is 1 minus 1 by 6 is 5 by 6. So 5 by 6 is our answer. That's all. Last question. A sheet is placed on a horizontal surface in front of a strong magnetic pole. A force is needed to. A sheet is placed. Now I am assuming that there has to be a magnetic material. A sheet is placed on a horizontal surface in front of a strong magnetic pole. A force is needed to. Now what will happen is it will be attracted. It will be attracted. So a force is needed to hold the sheet there if it is magnetic. Yes, you require a force because it will be attracted towards the magnet. Hold the sheet there if it is non-magnetic. No. No. Move the sheet away from the pole with a uniform velocity if it is conducting. Yes. If you want to make it move away, okay, then you require a force. Definitely you require a force because magnetic force is attracting towards it. You want to take it away, you have to apply the force. There is no doubt. This is also correct. Then move the sheet away from the pole with uniform velocity if it is both non-conducting and non-polar. No. If it's a non-conducting, then there is no forces acting on it. Right? If you want to make it move away, then anyhow there is no magnetic force acting on it. So definitely you will apply the force, but if it is a uniform velocity, then why to apply a force? Okay. So answer should be A and C only. Okay. So that is all. So there were a lot of easy questions. It was not that it was a tough question paper. Maybe we can find easily there are at least 28 to 30 questions easy in that. And maybe 10 to 15 questions were, or maybe 17 questions were, we can say, lengthy or slightly tougher. Okay. So scoring 100 or 120 marks is very easy in this one. Okay. So that's all from me. See you then.